Hi, this is Ashley Price. This is the Lewis structure project. So I decided to do an example of the nitric acid, which is represented by HNO3. There's some general facts for you about the nitric acid molecule, and I'll go over how I got those numbers and everything. So the first thing that we do when finding the valence electrons, it should be a step one for determining how to draw the Lewis structure. So with that, you can find valence electrons by using the periodic table. So I kind of just abbreviated the ones that I needed for the nitric acid. So it's the HNO, and then so you need 3, so it comes to 18, 5, and 1. So that is how you get the valence electrons. And once that's all added up, it comes to 24. After that, we will find the octet electrons. So before we do that, we have to know the general exceptions to the octet rule. So I wrote down some of the exceptions that could fall into the octet rule not being obeyed. But with the molecule that I'm using today, it does follow the octet rule, so we don't have to worry about those for today. And let's see, so I wrote out next like a little chart for the nitric acid molecule. So it has the octet electrons. So those are also found by the number of electrons that can be found at the top of the element on the periodic table. So with that, there's 2, 8, and 8. That's what would take to fill up the electron shell to make it happy. So with that, kind of falls into the octet rule. So that's the atoms sharing electrons until they're at a happy state, meaning that they're all filled up with the 8 valence electrons. However, with hydrogen, it only needs 2 to make itself happy. So at the bottom, I added all these up. For the octet electrons, there's 34. And then for valence electrons, there is 24. Let me see. So with that, you minus the octet electrons from the valence electrons, and that gives you 10 bonding electrons. And then so you divide those by 2 to give you the 5 bonds that will draw in the Lewis structure in just a moment. And then from there you have to take the valence electrons minus the electrons that are in the bond, and that is going to give you 14, which is going to be the leftover electrons remaining. So with that information, we're able to make a Lewis structure. So give me just a moment, we will make that structure. So let's see. So we already know that we're going to have 5 bonds, so you set that up. So we are going to do, then again it's nitric acid, so that's going to be the HNO3. So we'll do we have to remember that since hydrogen only can have 2 in it to make itself satisfied, you have to put that on the very end. Alright, so there is the HNO3. So we have the 3 oxygens, 1 nitrogen, and 1 hydrogen. So with that, we have our first bond, second bond, third bond. We have 2 left over, so we're going to do a double bond for the nitrogen over to the oxygen. And then we still have to fill it up the rest of the way to make it satisfied and stable. So with that, give this one. And then so for the nitric acid, that is what the Lewis structure should look like. And then we found that all by going through the process for the valence electrons, octet electrons, and we were able to find that to create the Lewis structure.